Okay, welcome everyone. Let's get started then. So welcome to the second in our series of webinars on FIPS cryptography. If you didn't see part one, there's a link in the chat right now you can follow to catch up on that after this one. So essentially what we did in the first part was that we talked about the kind of general context, and today we're doing a deep dive. We're really going to go into some low-level technical stuff and really see the details of how we work on an application to get it compliant with FIPS cryptography rules. So first, just to introduce myself. So my name's Graham Steele. I'm the CEO and founder of Cryptosense. So I have a technical background. I used to be a researcher in applied cryptography. So I was working in Germany, in Italy, in Scotland for a while, and then for 5 years here in Paris, France. And while I was working on applied cryptography, we frequently had the experience that we were working with industrial partners who were struggling to get a handle on all the cryptography across a large estate of IT, right? So trying to get the management of this stuff right, find out what's going on, find out what needs fixing, and particularly find out what's not compliant with the standards that apply to us. And so that's where Cryptosense came from, the desire to create software that would help people to get cryptography right. So our mission is essentially to allow all of our customers to protect all of their sensitive data by making it easy to deploy secure and compliant cryptography everywhere they need it. So that's what we're all about. So let's dive right into the subject for today, which is FIPS cryptography. So the FIPS standards are maintained by the National Institute of Standards and Technology. So this is a US government agency. And they maintain a set of standards called the Federal Information Processing Standards. So this is FIPS. And these FIPS rules give guidance to anybody who essentially wants to supply the US government with a piece of kit that's going to process information. And it gives all sorts of interesting standards in there. And these standards have become a much more wider uptake than just being used for suppliers to the US government, right? So they become a sort of de facto standard set for other sectors in the US and also for other countries, indeed, who use these standards to supply a kind of easy way to stay up to date with certain standards. Not everything in FIPS is about cryptography, but FIPS 140 describes a standard for cryptographic modules. So a lot of the time when people say, oh, FIPS cryptography, what they actually mean is FIPS 140 compliant cryptography, or cryptography implemented with FIPS 140 compliant modules. So the standard describes what you need to do if you are manufacturing or building or writing a software library that carries out cryptography in order to become compliant with the FIPS 140 standards. And there's a whole validation process behind that with laboratories who are accredited to do that validation, and a list of modules which are certified that's always kept up to date that you can search through. So that's what the FIPS 140 program is all about. So why might you need this? Well, obviously you might need it if you're building a cryptographic module, but that's not the most common use case in terms of the number of people who need the standard. So if you're implementing, for example, recommendations of the NIST framework for security and privacy controls, which might apply to you in a regulated sector in the US or healthcare or banking, something like that. Or if you are a software vendor producing a product that you would like to get approved for use by the federal government in the cloud, so sort of SaaS product, for example, then you'll want to be compliant with FedRAMP, and that requires FIPS cryptography through a certain set of its standards, the IA7, SE12, and 13. If you're interested in PCI DSS compliance, so the definition of strong cryptography, which is what you have to use to protect notably cardholder data, for example, refers back to this NIST definition, which is encapsulated inside the FIPS 140 requirements. And so we go through this in a lot of detail in the first webinar in the series. So I'm not going to dive into all that today, but there is a whole story behind the evolution of FIPS and what you have to be compliant with to do different things and so on. But anyway, so we assume that you know what FIPS is, and so you've come to this webinar to find out more about how to get FIPS compliant. So suppose you have a product and you want to make it FIPS compliant to pass one of these audit regulations. What we're going to deal with today is a deep dive into how to discover the cryptography that's inside that product, how to assess the FIPS compliance that it has, and sort of how to work towards getting it more compliant by fixing, in particular, the common issues that we see here at Cryptosense with our customers' products when they initially do a FIPS audit. And then at the end, how are we going to show compliance to the auditor to get our audit done and smoothly passed as smoothly as possible? All of this will demonstrate the principles, but we'll also demonstrate how you can do it using our software. Okay, so I mean, you don't have to use our software, of course, but if you do, our customers find is basically a huge productivity increase in being able to do it. But the principles that you'll see in the webinar today would also be useful if you wanted to go ahead, try and do this by hand or whatever. So there'll definitely be some pickups in here, even if getting hold of a tool is not on your map. So just to be completely clear, we're assuming that what you've got is a whole solution, so an application that treats sensitive data and has to protect it in a FIPS compliant way. We're not going to talk today about how to build a FIPS compliant library module, so not how to write your own cryptography library and get it through FIPS compliant. That's a whole other subject, and that's not going to be the subject today. So let's treat the first bullet. So the first thing we need to do, we're starting a project. We're going to try and get FIPS compliant with our new SaaS product. And so we need to figure out, okay, well, where is this existing product actually using cryptography? And a very common experience customers have is that applications have a lot more cryptography in them than you think. So the reason for this is that when we think about an application's use of encryption, signature, hashing, whatever it is, we tend to think directly about the business logic of the application, right? So if this application protects a file, then it's probably going to have to do it by specifically encrypting that file. And so that's the part that I think about. But applications tend to have a lot more auxiliary cryptography in them that do all sorts of important protections that keep them safe in terms of authorizing access, coordinating communication between different parts of the application and so on. And a lot of that cryptography happens through third-party components and libraries that we might have brought into the application, and maybe not directly through code inside the business logic. But we need to get all of that FIPS compliant if that's involved in actually protecting the application in order to pass our audit. So how might we go about discovering the cryptography in there? So we could do it by hand, right? So we could just load up all the code that we have and start searching for cryptography related strings, or we could come up with some nice patterns and do a sort of, there are a lot of tools similar to grep that you can use for querying very large code bases these days, which are pretty fast. But there is automated tooling to do this. So I'm going to show you just how we would do that if we were picking up a new application with the Cryptosense tooling. So let's suppose we've got a jar file. So I'm going to talk a lot about Java today, but of course these principles apply to whatever application framework and language you're using. Suppose you picked up a jar file and you know it's got your application in and you want to know where the cryptography is in there. So at Cryptosense, we have a little tool for doing this. So it's a little static crypto scanner. And all you have to do is tell it where it is you want to look for jar files. And so in this case, I'm going to look at a build of the application Jenkins. So I should say that we're going to use Jenkins as an example today. And the reason for that is that back in 2018, Cryptosense, we ran our tooling over the Jenkins open source build. And we found a bunch of crypto issues, which we reported to them and now have all been fixed. So this years ago, these results. But I'm going to use some of the old traces from back from 2018 in some of the demonstrations today, just to show an example of some of the non-compliances that you might find in an application that you pick up for the first time. But I want to emphasize that all those issues have been reported and been fixed since this set of tests was made. Anyway, so I'm now just going to scan this jar file to sort of find out what's in there. And so our little crypto scanner is going to dig its way through the classes in the bytecode and essentially scan for any call site which is calling out to cryptography. So the result is a whole bunch of these call sites, so a whole bunch of ways that the application code could be calling the cryptography libraries. If you've got a very sharp eye, you might have noticed that a lot of these are essentially kind of wrapper code. So these are bits of the Jenkins code which are wrap around the calls to the cryptography library. Things like the HMAC thing there and the RSA key thing there. And so if you're actually trying to find out, okay, what are the sort of call trees or the execution paths in the application that might call cryptography, you actually might want to go a few levels deeper. And our tool will do that as well. We'll actually recurse through the call stack. So you can give a parameter to say how deep you want to go. So in the first pass, we'll find the call sites that call cryptography. The second pass, we'll find the call sites that call the cryptography, and we can build that up. So essentially we can find all the ways, all the lines of code that might lead to a call that leads to cryptography inside your code. And there's a little summary here of the kind of things that we found. And so you can see it's actually quite a lot of cryptography going on inside Jenkins. So I don't know what came to mind when you thought about Jenkins straight up. You probably didn't think that there was going to be all sorts of cryptographic operations in there. But if you think about it for a while, a CI management tool is going to have to deal with updates to its plugins. It's going to have to deal with different Jenkins components talking to each other, API keys. There's actually quite a lot of cryptography in there, and that's a very typical experience when you pick up an application for the first time. So this is one approach, at least, to scanning for calls inside an application. Of course, this output is a little bit hard to digest, but as we'll see in a minute, we can actually upload this to the Cryptosense Analyzer tool and get a more useful set of information to work with. But anyway, the first step is to discover that cryptography and figure out what's actually in there. So the next thing we want to do is find the non-compliances. So typically the first thing that people do when they want to get a FIPS compliant version of their application is to switch in some FIPS compliant providers. So the way cryptography works, whether it's in Microsoft Windows and .NET, or whether you're using OpenSSL and you want to use the FIPS module for OpenSSL, or you're using Java, is you've got these providers that actually implement the cryptography. So these are the modules or the libraries underneath. And typically what people do is they don't try and change the application code first up. They say, well, let's just try switching in the FIPS compliant providers that have been certified and see if the application still works. It's not an unreasonable thing to do. And so if you're in the Java world and you're going to try this in software, what you probably do is use the Bounty Castle open source library. Has a FIPS compliant mode, so you're going to use that. And you switch that in, and so you reconfigure the providers, and we'll just look at how that happens in just a second. And there's typically two things that then happen. Either the application still runs, but it's not actually using the FIPS provider, it's still using one of the old providers, in which case this won't pass the audit because you need to execute that cryptography within a FIPS certified module. You can't just say, well, I'm using something which is compliant. Or you make it so that the application can only use the FIPS provider and only use it in FIPS mode, and then the application typically crashes. So crashes in the sense that it stops working because it tries to call some cryptography which is not allowed by FIPS. And of course, the FIPS provider will just stop at that point. It refuses to do anything. So the challenge at this point is to figure out what's actually going on. So to separate between these two cases and figure out what it is that we need to do to fix, to get our application to a state where, first of all, it's always using the FIPS provider, and secondly, it's not crashing because it's only doing FIPS compliant operations. So the way that we treat that in the Cryptosense toolsuite is that we then look at actually running the application and using our tracers to pick up the calls that are going on. So we're going to launch the application. So what I would do to launch Jenkins normally is something like this. So I just say, I'll go ahead, launch Java, and use that jar file. So if I want to use Cryptosense to pick up all the calls that application makes to its crypto libraries and put them in a log file, I basically just have to add a call to a Java agent, which is in the directory under there. That's the Cryptosense agent that's now going to run alongside it. So I haven't had to recompile my code or anything like that. And I can just launch Jenkins as I would in the normal way. Let's go ahead, and it's starting up in the background, loading its plugins and all that kind of stuff. It's up and running now. I'm just going to kill it off. So what I've got now is a traces of the what actually just got executed then. So we can see I was using this before, just before the demo. All these trace files contain all the cryptographic operations that Jenkins carries out as it calls its cryptographic libraries. We can even just look at one of those just to see what kind of stuff is in there. Just do one that we just did. So we've got everything. We've got all of the calls. We've got all of the call sites. We've got the full stack traces. We've got all the parameters that are used. But of course, this is not readable. This is just a sequence of JSON objects. What we're going to do with that trace is upload it to the Cryptosense Analyzer Platform, where we're going to make some sense out of it. And before I do that, I can also add in information from the static scan. So I can scan the WAR file and say, add into that trace all of those call sites. And now I've got a trace of what actually executes when the application goes, and I've got the sort of calls where it can come from. Now I can do some useful things that will actually help me figure this out. So here we have what we'll get from the result of that. So here is one I prepared earlier, as you could say, where I've actually scanned the Jenkins from its 2018 version, as I've said before. So it's an old version of Jenkins that has these issues that I want to pull out. And what I've done with that trace is I've run it through our analyzer. So you can see the analyzer is running here in its SAS version on our own servers. I've run it through the analyzer, and I've used a profile. So what we call a Cryptosense profile is a set of policy rules that is going to check to see, is this application using a FIPS provider? And so if I go and look at the non-compliances, I can see that all my non-compliances are coming out of one category, which is using a non-FIPS compliant provider. And basically what I've now got is a list of all of the cryptographic operations that were carried out that didn't use the FIPS provider, which in this case is actually all of them. So I have actually put the Bouncy Castle FIPS provider in this install, but because I didn't reconfigure the provider list, it's not going to know that that's the only one that we're allowed to use. So in fact, configuring Bouncy Castle to use FIPS it's pretty complicated. We have to make sure we put the right files in, we have to make sure we set the right providers, and then we have to change their order, and then we need to actually at runtime refer to the provider name to make sure those things are cool. So it's quite easy to have calls in the code which don't use the FIPS compliant provider, even if I've put that FIPS compliant provider in. Just to have a look about where they are. So if I click on one of these, then I get these operations. These operations are grouped together because they've come out of the same part of the code. And if I go ahead and click on an operation, I can then scroll down and see exactly the call stack where this came from. So here I'm doing some HMACking, and that's coming out of this load that's going on for these properties here. And I can see that I'm using SHA-256 as perfectly compliant operation. So SHA-256, as you'll know if you attended the previous webinar, it's totally compliant under FIPS. The problem is that it's not being executed by a FIPS compliant provider, and that FIPS compliant provider also would have to be in FIPS mode, which is another thing that we can check at runtime in order for this to really comply. So now I know where I've got to make sure I've started to use the right provider. But of course, we know that if we do put the application into a state where the only provider it can get its hands on is the Bouncy Castle FIPS mode provider, what's going to happen is that the application is going to stop as soon as it has to call something which is not FIPS compliant, so something that the Bouncy Castle FIPS will refuse to do. So we can also analyze the trace with respect to the FIPS compliant profile for Bouncy Castle. So what we're doing now is looking at that trace using Cryptosense. It's looking at every call and filtering the calls which don't comply with a rule for FIPS. These are exactly the rules that we went through in the webinar part 1, all those different particular requirements that you need to have in order for your cryptography to be FIPS compliant. So for example, we can see that there's a short RSA key in here that's 1024 bits. It's been used for 6 verification. So we might wonder, okay, what is that? These have been grouped together again because they've come out of the same parts of the code. And if we scroll down, we can have a look at these. And we can see what it is. So what's going on here? Well, there's some calls to an update manager for plugins going on. And you can see that we're getting some signatures back as part of that. So as you might expect, if you're not going to accept updates until you know that they're signed. But this is being checked with a 1024-bit key. And so that wouldn't pass the FIPS rules. Again, just to emphasize, this is from 3 years ago, and all these issues have been cleared up now. But you can see that if we were to run this with a FIPS only provider, this would actually crash at this point. And we would have to just dig back through the stack trace and try and figure out why, crash after crash. Whereas here, what we have in Cryptosense is a sort of map, a kind of cartography of all the cryptography that's in there that isn't passing FIPS, so that we can go through this issue by issue in one go, allocate the issues to the right people, and then very quickly get on the way towards FIPS compliance. So one other thing I want to point out is this weak key store stuff. So there is a mode of storing keys called a JKS key store, which is very problematic. In this old version of Jenkins, this JKS key store is used for storing a private key. And this would actually not pass FIPS. And so I'll explain exactly a little bit why that is. So if you are using Java and you've gone with Bouncy Castle as your FIPS provider, it will only accept these Bouncy Castle FIPS compliant key stores. But almost all applications still have some JKS key stores around, the original key stores that came out with Java, and these are not acceptable. The reason they're not acceptable is because they don't really encrypt keys at all. This design of key store came from a time where it was very problematic to export strong cryptography from the United States. So these guys created a key store format where the private key value is not actually encrypted, it's just XORed against a key stream that's generated from creating a SHA-1 hash of a password. So this is totally not strong cryptography, and so no reasonable application would want to do this, FIPS compliant or not. But in particular, Bouncy Castle will refuse to deal with a key store unless it's in the Bouncy Castle FIPS compliant key store format. So the Bouncy Castle FIPS compliant format uses a modern password-based key derivation function and modern encryption modes and encryption ciphers to do its encryption. all of which pass FIPS. And so that's what you have to use. So you need to migrate those Keystores from JKS to BCFKS before you can start using the Bouncy Castle FIPS versions. Another very common non-compliance is using cryptography, but maybe not for a critical purpose. So for example, MD5. So let's have a little look at an example of that. So let's go back to here. So let's for a FIPS not approved hash function. Okay, so here we have MD5 being used. So this is very typical. Let's have a look at an operation that's using MD5. I'll scroll down a little bit and see where this is coming from. So what we've got here is a cross-site request forgery crumb that's being generated using MD5. So the idea of this is you want to make it much harder to do cross-site request forgeries by creating a temporary token that's assigned to the user and the session so that it can't be hijacked by somebody else with a malicious web app. So in this case, it was the MD5 function that was being used to create the hash of this data that's going to become the crumb. So with my cryptographer's hat on, you could say, well, it doesn't matter that much that you're using MD5 for this because these things are short-lived. And so nobody's going to have time to brute force MD5, even though it has a relatively small 128-bit fingerprint in the time it would take for this thing to be an attack. And the collision resistance property of MD5 isn't really relevant for this. But because this bit of code could easily be considered by an auditor to be security critical because it's around the protection against these CSRFs, you're probably going to have to change from MD5 to a FIPS compliant hash function to get this through an audit. But in other cases, you might find other things going on with MD5. So typically we see things like just a sort of a username hash, so some sort of identifier being created to go in a table. And we don't mind about collisions. And there you might be able to make the case that the usage is not that critical. And so you might not need to fix it. So that's why it's very useful to have this map of all of the usages that you've got of these functions, to be able to go through them one by one and see them and then be able to issue them to the right people to fix. So in certain audits, we've talked to people who run the audits, people who advise auditors, and people who've been audited on the ground. Do you actually have to fix every single usage of a non-compliant function? And as far as we've been able to tell, it depends a little bit on the audit. So if you've been asked to do a strict FIPS compliant version of your software for whatever reason, well then yes, you do, because the auditor is going to want to see every single cryptographic call and be able to be sure that there are no FIPS non-compliant or not FIPS mode modules in use anywhere. But in some cases, we have seen in other regimes, it might be enough to be able to show that this usage is non-cryptographically, there's no cryptographic sort of security argument behind this usage. But in any case, having that map and being able to point them out to the auditor is a vital point to be able to getting towards a state where this thing is really compliant. So showing compliance. So typically the auditor will want to be walked through all the cryptographic protections that the application is using. So there'll probably have to be a story around what it is that the application is protecting. So what kind of data, is it PII, is it business critical, is it citizens, whoever it is, then what cryptographic protections we're applying. And then we need to show why these are FIPS compliant for all of those. So this is something that the Cryptosense tooling can also help with. So we don't just point out things which are wrong, we can also show things which are working. So if we quit out of this view of the hash functions, we can see that these are the failed rules, but we also have passed rules. So let's have a look at the uses of the ciphers, for example. So we can see that we've passed this FIPS compliant rule. Are we using FIPS compliant ciphers? And here we can see we're using the AES cipher in these operations, and we can go ahead and see where that's being used. That's being used in some calls here, coming from some encryptions of confidential keys. And so again, for all of these, we've got the map back into the code, and we can show the auditor exactly what's going on there and why we can believe that it's compliant. So it's allowing for certain ciphers, and we're complying with that for these ciphers. So essentially the game, once you've got Cryptosense up and running, is to move things from this top gap of failed rules into this bottom thing of passed rules. And once everything's in there and you've got a nice green report, you've essentially got the material that you need to explain to your auditor why your application is FIPS compliant and why it's protecting data in a FIPS compliant way. And that's what can become your audit artifact. Okay, so once you are compliant, of course you want to stay compliant. So normally applications don't stay exactly the same. There's always new features being added and new refactoring and optimizations going on. What you don't want is to have to repeat this rather time-consuming exercise of showing that it's FIPS compliant again. So what you can do with our tooling is integrate that tooling into your CI. So the tooling has an API, it has native integrations for certain Java build engines, for example, like Maven and Gradle. You can also integrate through the command line for other languages. It also supports Microsoft.NET and programs that call OpenSSL. And then you've got essentially a sort of cop that's keeping an eye on your application all the time as it changes and making sure that no non-FIPS compliant cryptography is introduced. And if you have exceptions, so if you have some of these non-cryptographic usages that you don't want to fix because it would imply too many changes to the code and won't increase the security, you can add them as exceptions. So we have a filtering mechanism where you can enter that line of code and say, don't show me any non-compliances coming out of that line. And that way you won't find that your builds are failing for things which you've already decided that you're not going to fix. So if you want to find out more about the Cryptosense Analyzer Platform, you can go to the Analyzer homepage. There's plenty more information there about what it does, what it's compatible with. If you want to give it a go, we're very happy to set up a free trial on our SaaS platform. You can ping one of my colleagues who is with us now in the webinar chat, and they'll be very happy to get in touch with you and arrange that. So thanks again for joining us today to learn a bit more about FIPS and the Cryptosense approach to getting an application to FIPS compliance. There's loads more information available. You can see our past webinar on FIPS and a bunch of other subjects. If you just register on the Cryptosense knowledge base, it's all one registration and everything becomes free to download. There's a bunch of white papers there on post-quantum cryptography, crypto inventory, cloud cryptography, all kinds of stuff. And particularly, we have a YouTube channel where you can stay up to date with all sorts of developing news in applied cryptography. Do take a look at that and consider subscribing. So I've just about squeezed that in under the half hour. I'll just take a look to see if there's any questions hanging out. Yeah, so can we run this tool with .NET? So absolutely, yes. The way that it runs in .NET is very similar to the way I showed you it running in Java. You don't have to recompile your code. The tracer works as a .NET profiler. So essentially, you just have to set an environment variable and launch the application, launch the CLR. And exactly the same thing happens. Every call to a crypto library that happens is traced and recorded into a trace, and the same analysis rules apply so that you can see all the FIPS non-compliances, the stack traces back into the code. So it works in exactly the same way. The version that works with OpenSSL relies on an LD preload shim. So this essentially is when you load the application, it loads the OpenSSL library at runtime. Our shim sits in between your application and the library and will pick up all those calls. And it's also able to show you whether the module that's carrying out the execution is the FIPS module and whether it's in FIPS mode. So that can be very useful, particularly for OpenSSL 3. And we've got a recent video on YouTube about that and about how it changes the way that you get into FIPS mode. And just a final question, is it possible to implement FIPS 140 without changing code? So only if you're very lucky, essentially. So you can, without changing code, you can, in most cases, you can force your application to only use a FIPS compliant provider. And there's various ways that you can read, for example, on the Bouncy Castle website about how there are various ways to do that with an application. But as I was saying, there was likely to be an issue when that runs. So more than likely, your application, if you're not prepared to change the code, is doing some non-FIPS compliant cryptography somewhere. And when it does that, it's going to, the module is just not going to reply. It's just going to refuse. And so that's going to point to where it is that you need to change some code. One other thing I should mention is that sometimes FIPS non-compliances can come from TLS configuration. So if you switch the TLS provider in Java to being the Bouncy Castle FIPS provider without checking the TLS cipher suites that you're calling, then that can cause a crash. Basically, the TLS load won't go through. So in that case, you may be able to fix that without changing code by changing the TLS configuration, which was probably, for most applications, it's in a configuration file somewhere rather than being hardwired in the code. And you can find those, well, you can find tips of that configuration on the Bouncy Castle how-tos, but the same kind of considerations apply wherever you're applying FIPS. So you need to check those cipher suites contain only options which are considered FIPS compliant and supported by the FIPS provider that you're using. Yeah, so the question about FIPS 140-2 versus 140-3. So there's quite a lot of changes in the procedure around getting modules validated for 143 versus 142. And basically there's a big harmonization going on between an existing ISO standard and the previous module validation framework at NIST to do that. But in terms of the things that we're looking at today, so the algorithm list of what's considered acceptable, and so what you're going to be able to get out of your FIPS compliant module when you run your application, for the moment that hasn't changed. So what you've got in FIPS 140-3 is a set of references to a set of documents on the NIST pages, but of course they can evolve over time. So NIST frequently does updates on things like guidance on key length and those kind of things. And so that can change, but at the moment, as we're just handing over between FIPS 142 and FIPS 143, they're still linked to the same set of algorithms and key lengths that were there in the standard before. Okay, I'll just do one more question before we hang up for the day. Does the tooling assess the quality of random number generators? So no, we don't have statistical random number generation tests included in there. So if what we do is check that you're using your provider in its compliant mode, which means if you make a call to it for its random number generator, for example, for key generation, then the tooling will show you whether that call went through while the provider was in its FIPS compliant mode, which should mean that the random number generation has been validated in the module validation program. So that's the way that it will help with that, but it doesn't actually do any specific NIST style testing of the random number generator. Okay, thanks everyone. That's been a really fun session. Thanks for all your questions and participation in the chat. So the recording will be made available to everybody. And as we mentioned, we're very happy to set up trials if anyone wants to give this a spin with one of their applications. Otherwise, if you've got more questions, don't hesitate to ping those to us directly. And anybody who haven't answered, we'll try and follow up out of band. And we'll see you again here at Cryptosense very soon for another webinar. Thanks very much for your time.